AC servo motor, it is constructionally similar to a two-phase induction motor. So there is a two windings are in AC servo motor. One winding is called as a control winding. This is called control winding. And another winding is called as a reference winding. It is called reference winding. So this is called EC and this is called ER. In between these two windings, the rotor will be connected to the load. This is load, we can find out, and this is rotor of the servo motor. The mechanical torque, motor torque will be in that direction, Tm, and load having inertia, we can say J, and speed will be angular speed theta or omega. So it is similar to two-phase induction motor. Out of two winding placed are in quadrature, both are in 90° apart. One of winding is excited by the constant voltage. It is called as a reference winding. The torque developed by the rotor is proportional to control winding voltage. So torque is proportional to EC. In servo motor, the rotor of servo motor is built with high resistance. So rotor is high resistance, so that X by L ratio is always small, and torque speed characteristic will be always be a linear. The torque speed characteristic of servo motor is almost linear, like this. This is torque and this is speed. So we can see this is the servo motor, AC servo motor, and if we compare with the induction motor, the characteristic will be like this. So this is the two-phase induction motor. So difference is there that AC servo motor X by R ratio is small. This is the difference. But in two-phase induction motor, the X by R ratio is not small. So we can see here Tm is proportional to EC, or we can write here Tm is equal to Km EC. Km is we can called as a Km is a motor constant at load. So at load we can find out at load Tm is equal to J d omega m by dt plus Bw. So viscous force is the inertia constant. So we can write in Laplace Tm s is equal to J s plus B into omega s. And also we know that Tm is equal to Tms is equal to Km time of we know that Km time of E is ECS from this equation number 1. This is equation number 2. So if we divide, we will find out omega s by ECS in Laplace. We can take Laplace, so it will be equal to Km upon Js plus B. So this is the transfer function of the, or we can write here Js plus B, and this is ECS. This is omega. So speed and voltage ratio is equal to Km upon Js plus B. This is the transfer function of the servo motor. So this is all about the AC servo motor. Thanks.